Hi, and welcome to the next webinar in 12D's training webinar series. My name is Lisa Stewart, and I'm the Marketing and Communications Coordinator at 12D Solutions. 12D's training webinars showcase common industry challenges, taking a close look at industry best practices and how they can be implemented using 12D products. The aim of these webinars is to upskill 12D users and broaden their understanding of the capabilities of 12D products. We run these webinars regularly and record them for posting through our website and on YouTube. The previous webinars from this training series, as well as the webinars from our Industry Solutions series, are all available on our YouTube channels if you missed those. While we wait for everyone to finish joining and get comfortable, I'll just launch a polling question. You'll have about 30 seconds to answer about why you're here, and then I'll show the results. Well, that's resounding praise for the session about to come, that we've got a lot of people who aren't just here because they're stuck at home, and 10% who didn't know there's a pandemic. So congratulations, you've learnt something already. So during today's live presentation, you'll be able to type your questions along the way. We'll put some instructions on the screen, and we'll answer as many as possible of those throughout the webinar. At the end, I'll read out some of your questions to the presenter for his insights if there's time. Today's webinar will be presented by Owen Thornton, who is both an engineer and a programmer, and has been writing, supporting, and using engineering design software for 2 decades. He joined 12D Solutions in 2003 as a programmer with an interest in design automation, and has since grown to become a 12D model specialist in drainage, utilities, volumetrics, plotting, and system setup. Owen runs regular 12D model training courses in drainage design, geometric design, customization, and 12DPL macro programming, or at least he does when we're able to run face-to-face training courses. Today's presentation, Stormwater Drainage Design Fundamentals, Give Your Water Networks a Geometry Lesson, is episode 3 in this series, which covers the basic and intermediate aspects of the 3 waters modules in 12D Model 14, with special emphasis on the design of stormwater drainage. This session will show the water network editor being used to establish links between water networks, geometric design strings, and crossing service strings. This simple little geometry lesson helps to fully integrate water networks into the project and sets a large number of parameters automatically. It also spares you from a considerable amount of manual drafting, measuring, and data entry, even when the designs change. Over to you, Owen.
Thank you, Lisa. Hello, everyone. Coming to you live from my home office in suburban Brisbane today. I suspect many of you are also at home. So this is episode 3 in this, what is probably going to be a 6-part series, Stormwater Drainage Design Fundamentals. And we're pretty much following on straight from episode 2. Episode 2 is where we created our water networks. And today we're going to give our networks a geometry lesson and integrate the water networks into our project and give the water networks all the information about all the other data in our project so that we can use it in the most efficient way possible and spare us from having to type everything in. In fact, one of the nice things about doing water design inside 12D model is that you very rarely have to type things in. A lot of things are calculated for you, and instead we spend more time sort of establishing links between different kinds of data and using that information to calculate the numbers that we need. Okay? So I've broken this down into about 6 different sections, and a couple of the sections here, 3.1 and 3.2 for episode 3, are just things that I was hoping to cover in episode 2, but I kind of ran out of time. First up, the explanation of the tabs in the water network editor. I gave the WNE, or water network editor, a little bit of an introduction in episode 2, but I missed out on explaining how the tabs work, and that's kind of all important. So I'll just do that quickly now. Into 12D, here's the project where we ended up at the end of episode 2. I'm just going to load up my water network editor and pick on a node to load the model into the network editor. And in episode 2, I introduced briefly this section at the top, which I call the navigation section for moving around the network. You can use the arrows and so forth to loop through. And I introduced the section at the bottom, which I call the control section, and we ran set node names, and I think we ran set node details and regrade pipes. I told you that if in doubt, press the buttons here. We also ran the plot button, but I think that was mainly it. We may have hit the string editor button as well. We certainly used the string editor, but I didn't really explain this section in the middle where all the tabs are. And there are a lot of tabs, which is why we call it the tab section. And mainly the main thing to understand here is this top row of tabs here, catchment, node, link, defaults, and global. Okay. And I sort of give these first three tabs the name of explicit, the explicit tabs of the network editor. If I click on the catchment tab, for instance, everything on the catchment tab is details relating to catchments that are flowing to the current node. The current node is the one that's currently highlighted by the editor. Okay. And they only apply to the catchments just for that one node. Likewise, on the node tab, all of the details on the node tab apply to the current node only. Okay, and yes, there are a lot of sub-tabs and there's a lot of details per node, but you don't have to fill them all in. And just to finish off the first three tabs here, the explicit tabs, on the link tab, this is the link downstream of the current node. Okay, in other words, the link where the arrow is pointing in the section view and in the plan view. Okay, but then there's these two rather more important tabs, and they're in capital letters there to signify that they are slightly more important, the defaults tab and the global tab. Both of but all of the settings on both these tabs apply to the entire water model. The difference being that a global setting, anything on the global tab is a global setting, and it applies to the entire model, and there's no override for it, okay? It's just a very much a fundamental setting there, and you can't override it. And we've already talked about a couple of things like linking the tins, and we talked briefly about node connection points and things like that, things of that nature. We're going to talk a lot about this utility models tab in this particular webinar today. But then there's also the defaults tab. The difference between a default and a global setting is that whilst a global applies to the whole model and cannot be overridden, a default also applies to the whole water model, but it can be overridden. So this is default data on the defaults tab here, default data for blank fields. That is a blank field on the explicit catchment, node, or link tab. Anything you leave unspecified on the catchment, node, and link tab takes its value from the default tab, and immediately below the defaults tab there are sub-tabs called catchment, nodes, and links, which is where all the default values are for anything that you don't specify explicitly. And this is by design, and it's all about efficiency. The idea is that you will set your defaults to be as applicable as possible, set them wisely so that they're widely applicable, and then you only need to go through and change possibly a much smaller list of nodes and catchments and links if they're different from the default, and set them explicitly. So once you understand the layout of the tabs and how they all work together, that is fundamental to understanding how the water network editor works. And the rest of it really is just detail and what's all the gory details on all the tabs there. And that's what we'll get into now. So that's the first little part of today's webinar that I wanted to cover, an explanation of how the tabs work. Also, in the creating of our networks from episode 2, one thing I left a little bit undone was the details at the outlet of our network. And there's 4 little parts that I wanted to cover here. One was setting the tailwater level, and that's very important. Once we get into the hydraulics, which we're not covering today, but once we do, the tailwater level there is going to dictate a lot of the starting point, really, of where our water is going to start. Because when we solve the flows in a water network, it tends to start at the downstream end. Certainly in the rational method hydraulics, it does what's called a backwater analysis. And the level of water that you set at the outlet can dictate how big your pipes need to be. The higher the water level is, the harder it is for the water to make its way through the system, okay, because the system is already a little bit backed up. And just a few other settings here, the Grate level, the outlet link invert or pipe invert levels in the final outlet pipe. Generally speaking, or 12D tries to grade them below the finished surface tin, but typically an outlet needs to daylight at the finished surface. So there's a couple of little settings there. And once we've got the levels of our outlet pipe established, we will then be able to establish the correct location for our outlet and extend our outlet link to match that outlet location. So let's have a look at that one now. Back into 12D, I want to jump immediately from the network editor to my outlet, which is in, remember this was network A if you saw episode 2. I'm just going to use the pick edit button and jump straight onto my outlet in the section view there. And I can tell it's an outlet first up because there's no arrow in the highlighter. It's just a circle in the highlighter. If I zoom right in there, I can see this is my outlet pipe that's discharging into the basin. And the first thing I want to do is set the tailwater level for this outlet. Now, even though we're not running the analysis yet, it's a good thing to do first up because there's a couple of other settings that are a little bit dependent on that. So I'm going to go to the explicit node tab here and go straight to the hydraulics tab, okay? And it is only on this section here that there's one little section called outlet data, and you'll only ever get this section enabled when you're on an outlet. Okay, 12D can detect it's an outlet because there's no downstream pipe at an outlet, and it enables this section. And this is here where you set the tailwater level, and you can do it differently for minor and major storms, but in this particular case, we're discharging into a basin, and that basin has a spillway right there, and that's really going to dictate most likely the tailwater level, the best tailwater level to use for this particular network. And you could just go and measure the level off that string, or you can do it directly here by going at point Z and just pick on one of those strings on the spillway there, and it's 28.8. I'll probably type in the same value for the major event as well, and that's all we need to do for the tailwater level. But having set the tailwater level, I then want to come over back to the explicit node main tab, and I actually want to set the grate level now, because by default, the grate level, and I haven't even explained really what the grate level is, and I am going to do that a little bit later. The grate level is really the maximum theoretical water level in the underground system, and it's hydraulically, it's a very important level. And in the case of an outlet especially, the only really important thing at the outlet is that the grate level is just a little bit higher than your tailwater level. So we just set our tailwater level to 28.8. I'm going to set my Grate RL manually to the level 29 and just hit apply or set no details. And you can see there's two little tick marks appearing in the section view at level 29 saying that that's where my grate level is. And that's just a little bit of a detail there. It's a requirement that we need if we're going to run this analysis successfully with that high tailwater up near that level. Grate level just needs to be a whisker higher. Okay, the only other thing that's looking wrong here is this outlet pipe. It's by default graded to try and maintain cover underneath our red finished surface tin here, but in truth, it needs to stick out of the batter slope a little bit and daylight and actually let the water out, basically. So we need to look at the grading on this pipe, and it's very tempting to just move over to the link tab, but there we get a message. There is no link on an outlet. So in order to edit the outlet link, we need to go to the node, the second last node in the line. So I'll just use the back arrow there. And now I'm editing the outlet link. Okay, one step up. Okay, and I'm going to go straight to the link design tab. Now on the link main tab, this is the explicit link main tab, I could just go and type in invert levels, and up here there are locks to lock those inverts to prevent the software from messing with them any further. There is an alternative though, and I try to avoid using the invert locks. In fact, it's this lock and this lock. It's a little bit, got to get used to that. The tick box is on the right of the word there. So you can lock the upstream and downstream invert, but I tend to try and only do it for existing drainage or for where I'm tying into something that's existing. But otherwise, for proposed elements, I try and leave these locks open. But here I'm just going to go to the link design tab here, And I want to first upset my grade mode from the default, and the default here is minimum depth mode. I'll explain, go into details on the grading a little bit later. But here I just want to set it to min grade mode. And in order to allow this pipe to daylight, grading at its minimum grade, which will be 0.5%, I want to tell 12D to skip the cover distance down over a certain distance downstream. In other words, ignore the tin for a certain length of this pipe on the downstream end. In other words, just give me the required cover on the upstream portion. And that's what this skip cover distance downstream value is. Now, this pipe is currently about 12 meters long, and about half of the pipe is underneath the batter slope there. So I'm just going to go half of that and then hit regrade pipes and set node details. And that has pretty much lifted up the pipe level there. If I just go back to the outlet pipe there, onto the node main tab, it's currently calculating the cover level. I haven't explained what cover level is yet either, but I might just change that cover RL mode to another setting here called maximum obvert, which is at this node, if there's only one pipe, it's going to give me set the cover level to the top of the pipe there, and hit set node details. Just looks a little bit neater cosmetically. Okay, the last thing I will do here is, now that I've got the levels of my pipe a little bit more sensible, I can see that my pipe is projecting out a little bit too far, and I'm just going to use the string editor to fix this. Click on the string editor button at the bottom of the network editor. That unloads the network editor and pops up a string editor panel here, and you can zoom in here, and I'm just going to use the one command under the edits menu here, edits extend, and I'm just going to pick on the downstream end of my pipe. And as I move it, I just want to try and get the top of my pipe as close as I can to that batter slope, somewhere there. In other words, we're shortening the outlet pipe there. Okay, it doesn't look like it's moved yet because I've also got the original plan plot labels over the top, but it looks like it's all looking good in the section view. So save and finish there. Load my model back into the network editor. If in doubt, press the button, set node details, regrade pipes, and let's replot that. And we should see that the head wall will shift from this position up to our new outlet position there. Just hit the plot button, and that's exactly what's happened. It's recalculated the length, re-established our 0.5% grade, and we're away. Okay, so that's all I wanted to do for detailing the network outlets. Moving on then, this is the main, most important part of the webinar now. We're now truly into episode 3, and this is linking geometric design strings to nodes. And this is all done through the network editor via a file called the road design file. And it allows us to link up to two strings to each node. One's called a set out string and one's called a center string. And typically a set out string, if you're talking about road drainage, the set out string will be one of your curb strings, and we can use the information on that curb string, such as its alignment, or bearing, if you like, and the levels on it, and extract all sorts of useful information out of it. And also a center string. Now this might be a road crown, or it could be the reference string, or both on your road. And with both of those strings linked into the node, we can do all of these things here automatically. We can rotate the nodes. We can provide set-out coordinates relative to the set-out strings. We can establish cover and grate levels relative to the set-out string levels if we need to. We can establish the chainage and offset on each individual road and allocate a road name to each node relative to the center strings we give it. This is the big one, the node location adjustments. We can adjust the location of our nodes lateral to the set out strings. Once we know where the road is, we can laterally adjust all our nodes to be exactly where we need them to be. In episode 2, you might recall, I didn't take a lot of care in laterally placing my inlets. I was mainly interested in where I placed them longitudinally along the curb, but not laterally, because I knew that I was going to establish a link to my road strings so that I could adjust them exactly, and we'll do that as well. Another big one is being able to measure the road grade and crossfall values in the vicinity of every outlet, and that is used for determining inlet capacity. It's quite important for the bypass flow determination once we get into the analysis. And more recently, it's also used for the visualization tri-meshes at nodes, often surface tri-meshes that you can link to your nodes. And it's more of a BIM thing for visualization in 3D. You can do very precise adjustments for grade and crossfall on those tri-meshes as well. And one thing that happens along the way, if you've got both a set-out string and a center string, you can determine if the node inlet is a left entry inlet or a right entry inlet, which is this certain asymmetry that all inlets have on roadways. So let's go through and do all of this now. Zooming back out a bit, we want to jump straight back into the network editor there, load our model into the network editor. And we can see there's the model name. I'm right at the top of line A0, which is my trunk line from episode 2. And I want to go to what I think in many ways is the most important tab on the network editor. And this is the Global Utility Models tab. And you can see at the moment, it's pretty much all filled in. And this was something that can happen if you use a water model template. And I recommend the use of a water model template because it means that you can have all of this set up in advance if you want. And in fact, a lot of this has happened automatically for us. You can see, if I look at my plan plot, for instance, my nodes are already rotated beautifully to the roadway. That didn't happen by magic though. It happened because of this file. If I were to imagine that I hadn't set all this up in advance, I can go through and just blank out these road design file, the service clash file. I'm not going to talk about catchments today or overland flow, but I'll blank them out as well. And if I go set node details after delinking that information and update the plot, suddenly this is what it would look like without a road design file. I can see my nodes are simply aligning with the downstream pipe, and they don't have the correct node rotations. Also, the setout point, which is this funny little symbol here, is simply in the center of the node where I place the node. It's not where it needs to be, typically on one of the curb strings. Normally, the lip of curb string is used most often in these parts. And so that is, if you had to sort that out manually, it'd be a lot of manual work there to go and rotate all of these nodes manually. Entirely possible to do, but why would you? Okay, so back to editor. Let's re-establish that road design file now. It's sitting in my case, it's sitting in my customer library. I've got two. In fact, I've got two models here, one called Stormwater, which is the one we created in episode 2, and another one called SWT, which I'll talk about a little bit later, because since the last episode, I've actually included another model called SWT, which is my transverse drainage model, which includes culverts and channels as well. And we'll talk a little bit about culverts and channels soon. Okay. What's inside this road design file though? This is just editing the stormwater model now. Let's have a look. Click on the folder icon. Now you can just create one of these files by typing in a file name, and then you click on the folder icon and select open, and it pops up a little editor for you to edit your road design file. Okay, this is what the editor looks like. I'll just expand it out a little bit, and it really can be as simple as this. On the first column here, the road strings model, you really just want to list all of the models in your project, and you can add new rows if you need to, but you can right click and it gives you the standard model list of all the models available in your project, and you list them out in terms of where are all these strings that you're interested in to be found in your project. In this case, I've got two models. One is my design 2 roads, because all of my roads have been merged into a single model here in this design 2 roads, and the alignment model, which is just these red alignment strings for the 4 roads that I've got in my road network here. And they're the 2 models I've listed because in each model there's a particular string that I'm interested in, or strings. Okay. In the case of the first row here, design 2 roads, I'm interested in the KL string, which is the lip of curb string. If I zoom right in there, I've got a whole bunch of strings on my curb. KL is the string code used in this project. In this case, it's KLL for the left side and KLR for the right side of the road there. KL star here in the set out string ID column will find all the KL strings, but there's a search distance here to say, well, that KL string needs to be within, say, 5 meters or whatever you type in there of the center of your node. And 12D will go looking for every KL string it can find in this model within 5 meters and return the closest one to the center of the node. And that becomes the set out string for that node. And it will do this for every node in the model. And it's not the end of the world if it doesn't find a set out string. Not every node needs a set out string. Okay, but typically curb pits do. So our sag pits and on-grade inlets will need a set out string. And that's all we do on that row. On the second row, it's even easier. I'm just saying, look in my model of alignment strings. These are the super alignments. I don't care what you've called that alignment. Just give me the nearest one within 25 meters of the center of my node, and that is the road that it will be linked to. Now, if any time it finds the wrong string, you can override that by manually picking on the string that you do want to use as a set out string or a center string, but it has to be listed in this file. The only other important thing I'll note at this stage is if you have changed the file, you must remember to hit the right button on this file, and then you can finish. But that's all you need to do to set up a road design file. It really can be as simple as this. Once you've done that, all you need to do is hit the Set Node Details button, because one of the things it does, amongst many things, is it goes and looks in this file and goes and establishes that link between your water network and your design strings and finds those set out strings and center strings. So here we go. If I go to my node, explicit node set out tab there, I can see that there's a string selection section here and I've got a blank set out string and a blank center string. But now that I've re-established that road design file, I can go Set Node Details, and suddenly these strings appear in the boxes here. And I can loop through the network checking all of that. And in fact, it doesn't look like it's changed yet, or you can sort of see there's a sort of a ghosting effect there. I've still got the original or the previous plan plot over the top of my water network. If I simply update the plot at this stage, it's starting to look a lot healthier and back to the way we had it. Okay, before I took away that road design file, and now I've re-established it and shown you a little bit about how to set it up. And so all my nodes are rotated, and you can loop through and check that all of the set out strings and center strings have been found the way you want it. In the process, it's also established coordinates, eastings and northings, and set out RLs for your set out coordinates, which are suddenly these have shifted from the center of the pit to where we wanted them on the lip of curb. Okay, the lip of curb has been nominated as our set out string, and that's where the set out points get calculated to. Okay, and this particular plot label has been set up to highlight those set out points. So as soon as you've established that link to your set out strings and center strings though, I would close down the network editor at this point, and now we can run another option outside of the network editor that's going to laterally adjust all of our nodes that are supposed to be near a curb to be exactly where they're supposed to be. Remember, I didn't take much care when I placed my nodes, and you see this gray lip of curb there. Well, in truth, for this particular pit type, the outside edge of the pit wall there is meant to align with that, and I'm not quite there. Now, some would say that's only a few millimeters. I would say in this modern BIM age that we're living in, I would say you do actually want to get your nodes millimeter perfect in terms of where they're actually going to be built. Opinions may vary on that point, but that would be my recommendation. And there is a tool available from the water toolbar under water, the second one here. What's this one called? Water string. It's the this icon here, adjust node locations. And it pops up this panel called adjust pit locations. You can also find it from the water string menu under plan edits, adjust pit locations. Okay. And this is a very simple panel to fill in. And it's also at the same time going to create a function. Now this little option here is a little bit like a computator in a superalignment and recalculating a superalignment that's got computators, because we've already got those links to our design strings, the center and the set out strings on most of our nodes. And as long as you've got a link to 2 strings at each node, we can laterally adjust the position of our node relative to the set out string. So shift it this way or this way, for instance. I just need to nominate my stormwater model name, SW, and simply on the road strings tab, I'm going to have this use road strings ticked on, and that means use the road strings we just linked in through the road design file using the network editor. And then I'm going to fill in this grid here. For every pit type we specify in this grid, we can give it an offset, and that is a distance for how far we want the center of pit to be from the set out string. And there is a sign convention there too. And look, it's to help you so you don't have to type it in every time and remember all this. You can establish a convention here and save it away in a file. And I've done exactly that. I've got this adjust pits offset, and there's different conventions that can be adopted too. I'm going to use the TMR one. I'm in Queensland. I'll use the TMR convention, and that loads all of my Queensland pit types in the grid here with the appropriate offset. And I've established these offsets simply by looking up the standard drawings for these pits. So in all cases, they're all positive numbers, somewhere, a little bit more than 1/2 meter. Some of them are a lot less than 1/2 meter. They're all positive numbers though, and that is the sign convention is a positive offset is moves the pit from away from the set out string to the outside of the road, and a negative offset moves it from the set out string towards the center of the road. And that's why you need the center string as well as the set out string to know which side of the road you're on. Okay, and so that sign convention is important. So it will only adjust the pit types that are listed in here. And if it doesn't have a set out string, all it's going to do is shift the pit onto the set out string, I believe. But if you've got a set out string and a center string, it will use this offset as well. Okay, and it's also going to create this function in our project called adjust pits, which means we can come and rerun this function anytime we need to if the design changes, or if we are simply move a pit or add a new pit. This is the option that's going to adjust our pits laterally to get them exactly where they need to be relative to the curb. Go ahead and hit the process button there, and it says 8 of 18 pits adjusted. If I hit it again, it says, oh, that's interesting, 1 of 18 pits adjusted, 0 of 18 pits. I'm not sure why it did that. Normally it just goes straight to 0. But if I regenerate my view, I've got this ghosting effect now because most of the pits in my network have just shifted there, and I simply need to update the plot. Okay, so let me jump back into the network editor. A little bit of housekeeping, because all we've done there is shift a whole bunch of pits in plan without adjusting the Z values, load the model back into the network editor, and the little bit of housekeeping I'm talking about is set node details, regrade pipes. You can see the grades in the section view may have just changed ever so slightly, and I'm going to redo the plot now after making those little adjustments to my node locations. I've now got my nodes more or less exactly where I want them. If I zoom in there, you can see all my nodes are perfectly aligned with the curb there, and the outside edge of my pit wall, or on the inside of the road that is perfectly aligned with my lip of curb. And that has moved my pits, and I've still got the same set out point right on the lip of curb as well. So that adjust pits function, which we now have available in our list of functions, is a good one to use and a good one to have set up. And I'll just do a quick demonstration of why that's useful. And I might just, for simplicity here, take off the labels, the stormwater labels, and just have the network on the view. Because now that I've got my pits in the precise location I want them, the question of whether this manhole here is in the right location is now something that we might want to reestablish and say, can we get this in a slightly better location, for instance? And also looking at the pipes coming into this manhole, those pipes look awfully close together. Now, we could probably use a larger diameter manhole there to space those pipes out, but at the moment they're too close. Maybe another option is if we could shift these pipes so that they're a little bit connected to points further separated on the perimeter of this boundary, because at the moment they're too close to build, and you'd sort of risk the structural integrity of that manhole if you tried to build something like that. So first up, let me just use this little option here. I did show this briefly in episode 2. This is the move point dialog from this icon on the water toolbar. And I'm going to re-establish, tick on the 2 tick boxes there, and I'm going to see if I can find a better location for this manhole. Bearing in mind that I want to stay inside the road reserve where that dashed red line is, and I also want to have my manhole in the exact center of this lane. I'm going to pick on the center of the manhole there, and I could probably push it a little bit, not too much. I'll just move it slightly down. And then I want to calculate the midpoint of the lane here. So SnapsCAD point midpoint, and I'm going to pick 2 points on my roadway here. I might do something like this. And that's going to calculate in the crosshair, the white crosshair there, the midpoint between the 2 points I've just digitized. And it's shifted the node there, and it's also shifted all of the other nodes from the other junction lines. Okay, I have connection points off at the moment, which made that easy. Now that I've moved that manhole a bit though, I've lost the perpendicularity of this pipe, and it's not that off, but just for the sake of it, I'm going to move this node as well and re-establish a perpendicular lateral. So I want to right click and be perpendicular to my curb line here. I can pick any of the curb lines, it doesn't really matter. And to re-establish a perpendicular junction here, just simply snap onto the center of your manhole's new location right there. And that will re-establish the perpendicularity of this lateral. Of course, that's placed it on the center of the back of curb, which is not where we want to have our pit anyway. We need to adjust this laterally, but that's the beauty of the adjust pits function. I can come back over to my recalc and just recalc that adjust pits function, and it shifts the pit for me exactly where it needs to be relative to the curb. Okay, so the only thing left is to fix these pipes at this particular node. So I'll just quickly show you how you can do that. Jump back into the network editor. And remember, I introduced this in episode 2, the use node connection points. I'm going to toggle the vertices on quickly on this stormwater model. So I can see I've got a cyan cross at the center of my of each node here. But if I turn on the use node connection points on the global main tab and go set node details, I now get a vertex at the end of every pipe, and I can shift those vertices if I need to. It's also snapped at the rectangular nodes there to the center of the best fitting side of the rectangle rather than on the corners there. So it is a better option. If you're, once you get to this stage, it's worthwhile turning them on. And I can tell there I've still got this issue where these 2 pipes are too close together to build. What I can do is, once I'm editing this node in the network editor, go to the node setout tab, explicit node setout tab, and I want to change the connection mode from points, which is the mode it's in at the moment, to this special mode called perimeter mode. And I'll just hit set node details to reinforce that. I possibly could have just hit apply. But now I can't actually move the connection points while I'm in the network editor. So I need to close that down, but I can come back to my move point dialog now. And again, I'll tick on the tick boxes, don't really need to, but I can, as well as moving the center of the node, this option is fantastic for moving the connection points once you've changed the connection point mode. I can slide that pipe wherever I like around the perimeter, and I might move it there, move it there, that'll do. And I might move this one a little bit away too. Okay, and if I were to do a quick measurement of the spacing there from, say, roughly that point to that point, I've got 170 millimeters. That's more than what I'd need. I typically need 150 mil spacing there horizontal total. So that should be perfectly adequate there. So just a little bit about connection points as well. I won't go any further than that. You could go through all the nodes that needed it, but not many of them in this network do need that. Whilst we're here though, I'll just finish off my train of thought here and load this all back into the network editor. I'll turn those connection vertices off again, and I'll add my stormwater labels back on. And you can see there's the slight adjustment that we made in moving that manhole. It hasn't just affected the one manhole. Everything is connected to everything else in a water network. All I need to do though is I'll probably want to run set node details first up and regrade pipes. If in doubt, press the button and then update the plot via the plot button there. And everything's back to where we want it in terms of the labels matching the water model itself. Okay, so one last thing I'll point out about that road design file, on top of everything else it's done, it's also automatically determined, say that this inlet here is a right entry inlet, whereas say this one up here is a left entry. So the water's coming down the road and turning left. Here the water's coming down the road and turning right. There is this asymmetry, and 12D's automatically handled that so that it can draw the right symbol for you and it doesn't look back to front. So a lot of things have happened because of that road design file. It's doing an awful lot for you. It's never a good idea to sort of think that you can skip that step of creating a road design file. All sorts of good things can now be calculated automatically because of that road design file. Okay, moving back to the slide. That's pretty much covered everything. I could quickly mention, actually, one thing I forgot was the road grades and crossfalls. I did mention that. Go back to editor, and every time we've been hitting set node details now, on the node, let me go to an on-grade pit, say, this one's a good example, A04. Every time we've been hitting the set node details now with our road design file, on the node bypass tab, it's also been calculating a road grade and a road crossfall. And it's been doing it in a little construction model. It's quietly behind the scenes created this construction model called construction drainage data. And I'll load that onto the view, and it actually, I've already got the string names toggled on for these two strings, but for every node there, we get a little cyan tick mark and a little magenta tick mark. And this is where 12D's actually measuring the grade and the crossfall in the vicinity of our node. So this is also why you need that set out and center string, so we can get these tick marks in the right orientation. All these tick marks are simply draped onto the tin. It's a little bit more complicated for the grade string, in fact, and you'll notice this road grade, it's actually calculated a slightly lower grade than what I would have imagined, something I only discovered recently, actually, and what I would probably do to recommend, it should have been calculated at slightly larger than 0.5%, because the road grade here is 0.5%, and we're on the inside of a bend, so it should be slightly steeper than that. And something that's actually happened here, what I would recommend to fix this is go back to the Global Utility Models tab, and let's just tweak our road design file here. Open this up. There are a couple of columns right on the right-hand side here that you very rarely need to modify. One is the grade offset, one is the crossfall offset, and the last one here is what I'm going to change, is the slope measurement distance. The grade offset says where it determines, all of these three columns here determine where these tick marks get placed on this in relation to the node. The grade offset by default is 1 meter, and the crossfall offset is 1 meter. That means 1 meter from the set out point, look 1 meter upstream from the node, and that's where you measure the road grade. And likewise with the crossfall offset, from where you've measured the road grade, go 1 meter into the roadway. And we know we're into the roadway there because our center string is there in the middle of the road, not on the other side out here. Okay. The one thing that's a little bit questionable here, though, is when you've got, by default, it uses a very small slope measurement distance of 100 mil, and that's why this tick mark is so small. If I were to make that 1 meter instead, and I don't really need these other values in there, they don't really hurt, but for both these rows, if I make the slope measurement distance 1 meter, that's going to make those tick marks 1 meter long, as well as being 1 meter upstream and into the roadway. If I hit the right button there, you must remember to hit the right button and finish and set node details. Now my tick marks are a little bit bigger, and if I go back to my node bypass tab, suddenly it's calculating the road grade more accurately. To be honest, it's not going to have a real impact in this particular case, but it might in others. So that's one thing I'd probably recommend there. Make that slope measurement distance a little bit bigger. And if at any time you're seeing funny road grades or crossfalls that you still can't fix out, it may have actually found a problem with your tin. And if you don't want to fix that, you can simply come in and tick a manual tick box on there and say, well, actually, no, I want to use, say, 0.51 exactly. And by specifying it manually, if you hit set node details again, that cyan grade measurement disappears because your 12D isn't calculating it anymore. You are. Okay. Turn the tick box off again. If you want to get 12D to calculate it, hit set node details. The tick mark comes back again. That's in the model, in the model called construction drainage data. Okay. So that just happens automatically, quietly behind the scenes. You can always check the numbers you're getting via that model. And also checking out the values on the node bypass tab for each individual node. Okay. Moving on. That's all I can tell you about the road design file. Moving on to this next section, 3.4. And this is just a few comments on grate levels and cover levels. I've mentioned them a few times already, but I really want to sort of tell you exactly what they are. And I've used the words grate and cover in quotes here because I kind of regret ever calling it a grate level. It was my fault. There doesn't have to be a grate at this node. There might be or there might not be. So every node, though, has a grate level, and for hydraulic purposes, it is probably the most important level, and it shouldn't be overlooked for hydraulic purposes. It defines the boundary between the underground and overland system in your hydraulic model, okay? And it's very, very important. Typically, you're going to set that grate level at a curb inlet to be exactly where the curb invert level is. And that's typically related to where your set out level is. Remember, our set out level is at the lip of curb. Well, typically your curb invert level is a certain distance below the lip of curb. And that's an important thing to know there. The cover level, on the other hand, that sort of defines an arbitrary top of the node. It's not used in the hydraulics, and it's really up to you where you want to choose to set that cover level. It doesn't have an effect on the hydraulics, but what it does do is the cover level is typically used to measure the depth of a node from. So the depth of a node is typically defined from the cover level down to, say, the sump level, or the depth to invert of a pipe is from the cover level of the node to the invert level of the pipe. So depending on how you want to define the depth of a node, and again, that is arbitrary, it's up to you or your verifier, that may determine where you set your cover level to. Both the cover and the grate can be set relative to the set out string. I've already mentioned set for curb inlet, set the grate level to match the curb invert level. And there is this one other setting here that we're starting to get questions about. There's a new level called the top level, which has been introduced in version 14, I believe. And this is more of a visualization thing for people producing BIM models. It defines the highest node level drawn in the section and perspective views, and also the highest node level you'll see drawn when you convert your water models to tri-meshes or IFC files, okay? So some people want to show tri-meshes at the surface for detailed things like lintels and grates and things like that, and they don't want the actual chamber or riser to go all the way up to the surface there, and they want to cut it off at some point. So it's not used unless you're doing detailed sort of BIM modeling, and I'm not going to cover it in this sort of more basic and intermediate level webinar. I'll just mention it here though. Okay, so let's go through a couple of steps showing this back to 12D. We'll turn off those construction models. And at the moment, all of my, if I go to my defaults nodes tab, this is where we can set the cover RL and Grate RL modes that determine how 12D is going to calculate the cover and Grate RLs for your network by default. Now, you can always override it on the node tab, but this is going to be the one we want to spend the most time on in the defaults and getting that right. Now, if I zoom into, say, a node at the top of my line A0 here, I can see my nodes are right up at the finished surface. They're right at the high part of the curb. Now, I did say I wanted my Grate levels certainly to be at the invert of curb, which is down here. And it's very important. That sort of 150 mil drop is very significant for a water network in terms of getting the pipe sizes right and getting your freeboard right. So in the first instance, I would say, well, let's get the Grate level correct. And I could set it to the set out string, and that's going to give me the level of the lip of curb, okay? But I actually want the invert of curb. So there is this other option here, setting the Grate RL to this option called SZ plus set out string, which is the level of the set out string plus this factor SZ. Now, what is SZ? It's actually on the neighboring tab here on the set out tab. It's a set out adjustment, okay? And in this case, I've already preset it to negative 0.04 or 40 millimeters below the lip of curb. And that is exactly what the level difference is between the lip of curb and the invert of curb in this particular job. Okay, so that's how SZ is set. And once you set the Grate RL mode to this SZ plus set out string and you hit set node details, like so, it draws these two little tick marks indicating where the Grate level is. Now this is the boundary between the underground and above ground hydraulic model. Okay, very, very important for hydraulic purposes. Okay, as to where you set your cover level though, you could leave it up there at the finished surface tin, but it depends. A lot of people I'm hearing, at least in my neck of the woods, and certainly on the construction side, they're asking for the depth of the node to be defined also from the invert of curb to the bottom of the node there. And so it may make sense to do both of the cover RL and the Grate RL to this SZ plus set out string. And if I do that, it drops both down. You don't see the tick marks anymore because the cover RL and the Grate RL are the same. Okay, now that's an option as well. And in fact, once you go to that level, you could even decide, well, actually, I'll just set the cover RL mode to this SZ plus set out string, and I'll set my Grate RL to be equal to the cover RL. Same difference, okay? A little bit more efficient to do it that way, perhaps. The only thing to be wary of here is at your manholes first up, and I'll just jump onto the node main tab here, and I might need to override that default at the manhole, such as this one here, node A03. It's got a default cover RL mode of the set out string, and it did actually find a set out string within 5 meters. So it's trying to give a level just below the surface there. And typically you want your manholes to actually go right up to the surface. So I'd probably on the explicit node main tab override the default just for this manhole and set that to finish surface tin, set node details, and it pops up to the top again. That's where I want it. You might think that this one, the next one down in this line, which is an on-grade pit. This is an interesting one because the invert level of the curb is below the tin profile here because our tin profile is on the high part of the curb. So our node doesn't come all the way up to the surface there. And some verifiers, if you saw that on a long section plot, they'd say, put a big red mark around that and say that's wrong. In truth, it's actually not wrong. And for a lip-in line pit like this one, there's actually, in reality, there's a portion of the curb that's cut back into the footpath or the verge there. And in truth, what's missing in the model, it's not that the node is in the wrong elevation, it's that the tin should actually be dropping down to meet that top of the node there before coming back up. It's just simply they haven't gone to the level of detail of modeling that into the tin at this stage because we haven't told them where to put the nodes yet. Okay, so it's just something that some verifiers will ask you to make it draw up to the surface anyway, and you can always do that if you want to by setting the cover RL to finish surface tin and doing that. And some people might prefer the look of that, but in that case, you'd probably want to set the Grate RL back to SZ plus set out string, set no details, so that we definitely want the Grate level there. However, it's really up to you how you want to do that. I might blank it out and leave it the way I had it. Set no details, and that's the way I'd prefer to have it. So that's all I really wanted to cover about the Grate levels and cover levels at this stage. There's more probably points to make there, but I'm mindful of the time. Again, I've gone over time. All my episodes seem to go over time. But let's just, a couple more points I wanted to make here. Grading of water strings and avoiding crossing surfaces. I'll try and cover this quickly. What we're talking about here is how does the regrade pipes button do its thing? And how does it avoid crossing surfaces? And what are node connection points and the definition of link length got to do with all of this? And let's sort of show you as best I can a quick overview of how it works. Okay, again, back to the most important tab on the network editor, the Global Utility Models tab. If I hit the Regrade Pipes button, it tells me in a nice green friendly status bar there that the invert levels have been reset successfully. But hang on a minute. If I look through my network here, I can see a couple of spots at least. I reckon I'm too close to the water main there. And in fact, I can tell I'm clashing with the water main there on this line A3. Well, that's not very good. Until we tell 12D, or tell our water model at least, in this service clashes area here with the service clash file, until we tell 12D about the services that are passing nearby or crossing our water network, the water model won't know where they are. So that's what the service clash file is. Again, you can type a file in and start editing, but I've already got one called sw.clash in my customer library. Again, click on the folder icon to open it up. And this is, in my case, it's very simple. I've only got two models, and these are the models we pre-configured in episode 1 when we pre-processed our crossing service models. I've got one which contains this cream-coloured sewer model, and this other one, PPF Cuts UT, which all it has in it is this sort of dull blue-coloured water main there. And there's a few different strings in each of these models. And all I'm saying there is these are the two models, and I want to be vertically clear of those two services by 300 millimeters. Okay, so it's only talking about vertical clearance first up, but 12D will be able to tell you if you're too close or in fact too far from these services simply by specifying them in this service clash file. Okay, again, if you've changed anything, remember to hit the right button. And once that's established now, if I hit the Regrade Pipes button, hey, we've generated an error. Before it said it was fine, now it tells me that the invert levels are being reset, but there are problems, and it's asking me to look in the output window. Let's have a look in the output window, and just to make it a little bit easier to have a look at this, I might right-click in the output window and untick Auto Hide, and right-click in it again and change it from docking to floating. And that allows me to resize this window into something that I can see and read easily. But basically, it's telling me that there's a whole bunch of crossings between my water model and those two other models, which are the sewer SS and the potable water strings in the water model, in the potable water model. And most of them are showing up with these info messages in green saying, hey, the clearance is more than that 300, the vertical clearance that is. But I've got 3 problem messages here. Now, these problem messages in the output window are not just dumb bits of text. Okay, I can actually double click on these, and as long as I've got the network editor open, it actually jumps me to the problem link in the network editor. And all I need to know how to do is to go to the explicit link design tab, because that is where the explicit settings for invert design are stored in the network editor for just this particular pipe. Now, it's also a little bit handy because it puts this highlighting on the screen. It makes the colors a little bit funny. So if that's confusing you, just click into the white space of the output window and it releases that highlighting. But it's taken me to the line, to the pipe AO2 to AO3, this one here. And it's telling me that my clearance is less than 300. I'm too close to this water main here at chainage 22 point something, okay? And it's also making a recommendation. If I increase the cover limit of my stormwater pipe to 0.819, that would solve the problem. Now, the reason it doesn't just go ahead and do that is it's just one possible solution. It's not guaranteed to be the best solution. A lot of the time it will be, but we don't want to automatically sort of potentially add $1 million to the cost of your network because we've just made that assumption. We want you to eyeball every one of these crossings, and really this process is really a process of eyeballing each individual crossing by double-clicking on the problem lines and setting the parameters the way you want to give you the best possible solution that's going to suit your job. We don't think that we can do this automatically enough, so I would call this semi-automatic avoiding of crossing surfaces. It's certainly not fully automatic. And we want you to have a bit of human input on this as well there. In this case, I probably will just accept the number here, and I wouldn't work to the millimeter here. I'd round that cover limit up to 0.82, and I'll come over to the link design tab, and in the cover limit box here, type 0.82 and hit regrade pipes. And it'll just drop down until I no longer have that problem message. I've still got 2 more problem messages, but the one that I just fixed there, the AO2, it's now telling me I've got a clearance of 301 millimeters. That's good enough for me. I'm going to double click on the next problem line. Now, these are both on the A3 line, so I tend to start with the one with the lowest chainage there. So I'll double click on that one. That takes me to line A3, and it's complaining about this one here. Now, here is a case where I would say don't accept the recommendation by 12D. That's going to push the whole pipe a lot deeper there when really I just want to drop the upstream end. So this is one of these cases where I'd actually recommend we set the grade mode away from the minimum depth mode, which is a good default for pits and pipes, but set minimum grade mode here and probably trial a grade, say, a little bit flatter than what we've currently got, just to drop that. I don't want to have an impact on the depth of the pipe here, but here let's try a grade of, say, I don't know, 3% and hit regrade pipes. Well, that's dropped it considerably, given me my 3% grade. It's dropped it considerably though, and if I look in the info section, I can find it AO3 there, oh sorry, A3. I've now got a clearance of 400. That's probably bigger than I need. Let's try 3.2 percent, not degrees. Let's lifted it up a little bit. And look, that looks pretty close actually. There's the 315 millimeters clearance. Let's call that good enough. So you can see that's a better solution, dropping the upstream end of the pipe rather than pushing the whole pipe deeper on the grade of the tin effectively, or the ground slope, which is what the other mode, minimum depth mode, gives you typically. It gives you the grade of the ground slope, but then pushed down by the cover limit. Minimum grade mode just gives you the grade that you specify there in the minimum grade box. Okay, still have one more problem message, and I'll just double click on that to jump me to this pipe right down the bottom here. And again, I'll probably do something a little bit different here. If I just accepted the recommendation there of 1.02, I'd probably round it up to 1.03 and just hit regrade pipes. it's pushing that pipe deeper, but it's still maintaining this pipe grade of 3.7 based on the grade between the two nodes there. And we can probably do better than that, again, by setting the grade mode to minimum grade. And we'll just blank out that cover limit for a moment. So this time it's going to give me a solution if it just sets it on the minimum grade of 0.5%. But now it's recommending, rather than pushing it to 1.03, I can push it just as deep as 1.01. So I've saved myself 20 millimeters or so. Okay, regrade pipes, and that's a slightly better solution there. It has introduced a bit of a drop through the system there, and whether or not that's acceptable, for small pipes it probably is, but you can do something like go to the pipe just upstream of that and set the downstream alignment mode, say, to align the obverts with this OL drop, regrade pipes. That's probably a bit of an extreme solution. Maybe a better one is this minimum drop less than downstream diameter, which effectively aligns the obvert of the downstream pipe with the invert of the upstream pipe there, and gives a compromise to not have an excessive drop through the system there. But honestly, you could just as well get rid of all of that and go back to the way we had it originally with a larger drop through the structure, because that's going to be cheaper to build with a smaller trench volume required. I was going to mention just briefly too, similar to on the global main tab, we talked a little bit about connection points and we shifted them around. We've now sort of taught the network all about our crossing services, and we've given them parameters so that the network, the regrade pipes button is going to be able to avoid those services, even when the pipe sizes start changing, hopefully, and probably. But there's one little point I would like to make here about connection points, and also this definition of link length. Now, these two tick boxes, use node connection points and use link end-to-end length. In this modern BIM age, I would recommend that you have both of those on by the time you get to this level, and you'll notice the difference it makes. This little tick box on the right, use link end-to-end length, actually changes the definition of what pipe length means. Okay, so looking at this, say one pipe here, I'll get my output window first of all back to the way it was, auto hide, give me a bit of screen space back. Just looking at this one pipe here, it's 30.5 meters from this manhole to this manhole. That is defined from the edge of the manhole to edge of manhole, okay? If I turn that tick box off, that's going to change the definition of pipe length to be from center of manhole to center of manhole. And if I just hit the apply button there, you can see the gap in the arrows on the section view has just disappeared, and all of the numbers change slightly, including the grade. It has an effect on the pipe grade as well. And my perfect 0.5% grade is no longer 0.5% because my pipe lengths are now defined a little bit longer than they were. Nothing has actually changed physically, it's just the definition there. Now, this old school definition with the tick box off is sort of becoming a little bit more outdated, I would have to say now, and especially when you're using connection points, I would almost always recommend you have this use link end-to-end length ticked on, and hit set node details and regrade pipes, and that set things back to the way they are. It's a subtle difference there, but often an important one, because especially for short pipes, you don't want your pipes getting flatter than your supposed minimum grade, and it will just cause verification problems more than anything else. Even though the invert levels may not be different, you're changing the definition of what pipe length means. Most of these connection points and link end-to-end, most of that has come from the construction side of the industry rather than the design side, because they've been giving feedback for years saying, give us models that represent what we actually need to build rather than these design approximations, please. So that's where it's come from, and that's what I would recommend. I do have one, I know I'm seriously over time now, and I do apologize, but hey, we're all stuck at home. What does it matter? I've got one last little slide here on notes on culverts and channels. Now, everything that I've shown you in, well, episode 2 and episode 3 has been shown on pits and pipes, but it's also entirely appropriate and applicable to culverts and channels, because culverts and channels are just another water stream, just with a few different settings. So I've just made a little slide here to show you some of the settings that are typically different between a culvert and channel system versus a pit and pipe system. So at culvert inlets, typically you'll set the grate level to match the overtopping level of the culvert. A culvert normally goes under a road, and normally the road level is much higher. You want to set your grate level to where the culvert is going to spill if the water doesn't make it through the culvert. So that's the boundary, I guess, between the underground and above ground system. At a channel node, where you might have, say, a trapezoidal channel rather than an underground pipe, the channel node is actually, arguably above ground, but we'll call it part of the underground system, and you'll set the grate level there to the top of the channel in a channel system. Okay, and there's a special mode, I think we covered it briefly, the maximum obvert mode there. That's the good mode to use for the top of your channel. It's a good idea here to add a channel link downstream of a culvert link for hydraulic reasons to help establish a tailwater condition there, if it's otherwise a bit questionable what the tailwater level is. If you are modeling channel links and nodes, as well as culvert links and nodes, in terms of matching the horizontal and vertical geometry, it's probably more important to match the vertical geometry of the channel that you're trying to model here. And I'll point out that the only reason you're creating channels as a water string is for hydraulic purposes. You're certainly not going to build the channels from the water model. You'll build the culverts and the pits and pipes from the water model, but not the channels. Okay, the channels are purely there for hydraulic purposes to test whether the channel is big enough hydraulically. But it's important to get all those changes in grade, so you want to have nodes at the changes in grade. It's also important to get the horizontal, but very much you want to get the changes in grade. Again, we've talked about the minimum grade mode briefly, which is a good one for culverts when they daylight. But there's another grade mode here that's very good for channel links called drape invert. So I'll just quickly show all of this. And this is in a completely different model. I've got my model here called SWT, which I'll profile one of those strings. And this is actually just another water string in this model called SWT. And I'll jump on using the network editor. I'll jump onto that model there. And you can see it's just another water string, and I can loop through there. But all of the orange parts of this are culverts, and then the grey parts here are open channel links. And I will post a link shortly after this webinar is over. I will post a link to this project so that people can download it and have a look for themselves, because this is a really good example of a culvert and channel system. It's also got a smaller culvert over here on line T2, which is just a single little culvert with a little channel link downstream of it that helps establish the tailwater. Now, the options that I'm talking about on that previous slide, just a couple of different things that are a little bit different for culverts and channels. Here you want to make sure at the culvert inlet here on this little culvert that's going underneath the driveway, you want to set the grate level manually typically, and to be right up where the overtopping level is. Here, this is, if the water doesn't make it through the culvert, it's going to overtop the level of the driveway there. That's where you want to set your grate level. That's quite important for sizing the culvert. The channel nodes, and even the culvert, the headwall node that's just down on the downstream end of the culvert, that maximum obvert mode is good, because that sets the grate level to the top of the channel link here, which is the next thing down. And on the link tab there, on the link main tab, you can set the trapezoidal shape, and you can set the color, which I've done. I've just done that for visual purposes to make it easier to see what's a culvert and what's a channel. Set the dimensions of the trapezoid there, but also the grade mode. Now, it doesn't show here because I've set it by default. Because on this culvert channel model here, SWT, because most of my links are channel links here, I've set my default to drape inverts there, which is one of the options on this option. If I went to the defaults tab there on defaults links, you'd see the default grade mode is drape inverts. And that just says set the invert levels of your pipe to match the finished surface tin. So that's really a handful of different things that I wanted to point out there about culvert and channel systems. I will try and provide a link to this project this afternoon for everyone to download. I'll put that on the 12D model forum. But that's where I'd like to end today. I know that's a lot of detail and I went seriously over time, but I'll open the webinar up now to any questions we may have had.
Thanks.
While I was talking.
Yeah, we had quite a few questions through. So even though we are over time, I think there's still lots of people here. So I think we'll anyone who has to leave can listen to the recording later. But Kate asked, would surface crossing clashes be better done after the hydraulic analysis when pipe sizes are known?
Well, most of the time you can get away with doing them beforehand, and those parameters that we set will still hold true even after the pipe sizes have changed. There's two schools of thought there. There may be a few cases after you run the analysis and the pipes get bigger, if you're sort of threading the needle between two surfaces above and below, there might be some additional parameters you'll need to add on there. But there's a school of thought that says, well, if you get your pipe levels at sort of closer to where you know they're going to need to be from the get-go, then your hydraulics are going to be more accurate as well. So the true answer is, you're probably not always going to get away with doing the grading before the analysis, the hydraulic analysis. You might need to do some additional grading parameters after the analysis as well. But I would say it's worthwhile doing the grading analysis beforehand and a little bit after, rather than doing it all afterwards.
Thanks, Owen. And Peter has asked whether you're able to use wildcards for models in the road design file.
No, the notion of model wildcards came a little bit after the invention of the road design file. It's possibly something that we could look at, though. I don't think it's ever actually been gone in as a wish. But you notice in my example there, where I only had the two rows in my road design file, one of the reasons I merged all of the models together in the road design is so that I could have a simplified road design file. It does make life easier for a whole lot of other 12D users who are dependent on the road design if you do merge those models together. If you don't, yes, it's just a big list of models there, and it's harder to deal with. But it's a good question, and it's something that potentially could be looked at. I'm not sure. I can't possibly nominate how easy or hard it might be, but it would be a nice little enhancement there.
Sure. Well, speaking of the road design file, John asked, what if my center string is not a reference string?
Yeah, that's an interesting one. It's actually a little bit of a tricky question, that one, because, and it doesn't happen so much in roads like this, because typically your center string is also the road crown or the center of the road, and it's also the reference string for your road. In other scenarios like big highway designs, such as a dual carriageway, your reference string may not be within the carriageway, or might be right on one edge of one carriageway, and it might be over the top of one of your set-out strings. And you do want a little bit of horizontal separation between the set-out string and the center string. There's not a great solution at the moment. What I would tend to do is say, use your reference string in the road design file for getting the chainage and offsets of your nodes, because that's what defines the chainage, is the reference string. Once you've established that in your road design file, you could probably set all of the road chainage modes to manual, so it won't try and recalculate that again, and then use possibly a variation in your road design file that actually then references the center lines that are a string in the middle of your road, because that's really ultimately more important, is to have that center string representing the center of the carriageway, because it's more important arguably to know for each node to know which side of the road it's on from a hydraulic perspective. So in that case, it's really an answer of having two different road design files and doing a bit of a switcheroo at the right point. It doesn't come up too often, that problem, but in dual carriageways it has. We have been looking at a proposal to actually support both a center string and a reference string as well, but at this stage it hasn't happened yet, so that would be the only solution I could offer.
Sure, okay. And we'll just do one more live and I'll email everyone else's through. Jenny asked, can 12D model grade the water strings to avoid services automatically?
Automatically. Well, I sort of touched on that in the webinar, but it's one that we've sort of balked at. In theory, we could grade all of our strings, and this is going through just at the end there when I was grading my network, and I'll just profile one of these lines from the stormwater model there, and we had the output window up and hitting regrade pipes and looking at the messages in the output window. We could have applied the recommendations that 12D made, but they wouldn't have given us the best solution. And we don't think our regrade pipes algorithm is always going to give you the perfect solution. It'll give you a solution, but there's more than one solution there, and we don't want to be liable for adding $1 million to the cost of your network. So this is why it's not automatic, it's semi-automatic. There have been discussions about, possibly allowing it to be automatic under certain situations. But we've kind of always walked away from it because of the risk involved of, not always giving the best solution. Whilst we could give a solution, we don't want it to be a solution that's someone could just manually look at and just say, oh, we could find a much better solution ourselves. So that's why we ask you to eyeball each one of those crossings and for you to use the parameters the way you want to give you the design that you want.
Okay, thanks for that, Owen. And yes, sorry to those we haven't dealt with live, but I'll email you through those questions very soon. So the recording of today's webinar will be available in coming days through the webinars page on our website and on our 12D Model YouTube channel. I'll also email the link to everyone who registered today, and I'll try and include links to episodes 1 and 2 in that email as well, so they're easy to watch the whole lot if you like. So keep an eye on our emails and social media for details of our future webinars. And if you need to contact us in the meantime, our details are on the screen now. That concludes our presentation for today. Thank you all for attending, and we hope to see you at future webinars.